is the first exercise that we're going to do. And so this particular lab exercise, we're looking at chance, okay? So it's kind of like mimicking independent assortment, where we take all this genetic material, we just kind of mix it up and throw it out there and say, okay, what are we going to get, okay? The first section of this particular exercise, what you're going to do is you're going to, make sure I'm on the right one here. You're going to toss coins. Okay, so groups of 3, and then I'll have a couple groups that will have 4. Okay, so what you're going to do is you're going to toss one coin 24 times. Okay, and then you're going to count. So you're going to count what is the observed number. So every time you flip the coin, how many times did you get heads? How many times did you get tails out of those 24 flips of the coin? Okay. So then you're going to determine your expected. Okay. So if we toss a coin, 24 times, what do we expect to be the number of times we hit heads? 12. Okay. So our expected times of heads should be 12. Tails should also be 12 in a total of 24. Okay. So after you've tossed the coin, you get your number of observed. We have then our expected. You then determine the deviation. Okay. If the deviations are small, okay, then we can say that the difference is just by chance. Okay, that's what probability means. Okay, it's just by chance that our observed was different than our expected. Okay, now if that deviation is large, then we would say that there is something else that is affecting what we're doing that caused us to get a difference between our observed and our expected. So that would be an example like if you have a weighted coin, right? If the head side is weighted every time you flip, it will give you tails, what have you, right? So that would be an example where there is something that is making us have this deviation between what we expect and what we are getting, okay? So you're going to complete that. That's the first part, okay? Now the second part, you go into independent events that are occurring simultaneously, okay? So now you're going to be flipping 2 coins, okay? And so you need to flip them together, okay? I've seen some like, can you flip the coin and I'll flip? No, you got to flip them together, okay? Meaning that they're occurring simultaneously, okay? And then you're going to observe what you get, okay? So do you get heads with both coins? Did you get heads, tails, or tails, heads? It doesn't matter. As long as it's 1 head and 1 tails. If you get 2 tails, okay, and you're going to flip the coins 36 times, okay? So, what would our expected numbers look like?
12, 12, and 12.
Would they be 12, 12, and 12?
12, 24, and 12.
Is that right? But that gives us 48, right? We need 36, right? So what would those calculations be?
7, 12,
9, 18, 9.
I got every number in the book. So if it's 36, okay, 36 divided by 4, how many times does it go in evenly? 9, right? So it should be 9. You were right, Stacey. Right? You had it right? Right? So it'd be 9. 9 plus 9. 18, right? And then 9. Now the reason that your middle is 18, because you remember it could be, I get head's tail or I get tail's head, right? So you would join those as being like 2 groups. So that's why it's 9, 18, 9, which then should total 36.
And you sum the probabilities because they're not
Are we summing or is it a product?
summing them.
So you have two independent events occurring at the same time. Remember we did the albino and a girl.
Yeah.
We multiplied, remember?
Yeah.
Because we had one situation, it's a girl, the other situation, albino. We multiply those probabilities to get an albino girl. So in this situation, again, it would be a product law,
Okay.
right?
Yeah.
So if I'm looking at heads and heads, right? Heads and heads, right? We just learned from the first part, it's 50-50, right? 1/2. So heads is 1/2. If I get another heads, it's another 1/2, right? And that gives me what? 1/2 times 1/2 is 1/4. Okay? So it is a product law.
Oh, no, sorry, that's a noun.
Okay? So it's a product law. Okay? So then after you complete tossing the 2 coins, there are some questions that you would answer on page 53. And then at the bottom in table 3, now you are flipping 3 coins. Okay? And so you're going to, again, look at the combinations. You're going to look at the probabilities. You're going to fill in your observed, what you expect, and then you're going to do the deviation, which is the difference between your observed minus your expected. Okay? Then you're going to toss 4 coins. And you're going to do the same things again. You're going to determine the probability of each class occurring. And then there are some questions for you to answer. Okay? Now the last part, which is section 3, goes into binomial expansion, which is a way in which you can determine probabilities. So in the situations they give you, they're talking about girls or boys. So like, what is the chance you're going to have 3 girls and 1 boy? Okay? And so they've done an expansion, and they've kind of given you an example of how they would use binomial expansion to identify probabilities. Basically try to make it easier. If you're, have memorized binomial expansion, right? Then you could use that particular situation to identify probabilities of certain circumstances. Okay? So they have, they give you an example, and I just want you to do number 1. Okay? And you do not have to do number 2, which I already have omitted on there for you. Okay? Are there any questions yet for me? And so then on page 56, they have question number 3. I want you to work through question number 3. It's very similar to what we did as far as Mendel, but now we're looking at probabilities, which is very similar. All right. Questions? No? So on chi-squared then, the first 2 questions of chi-squared is asking you to pull data that you did during your principles of probability.
Are we doing 4 and 5?
No. You don't need to do 4 and 5. So with chi-squared, if you turn to page 64 and 65, those are the only 2 pages out of chi-squared that you're going to do. So on page 64, it's asking you to pull your data from tossing 1 coin. On page 65, it's asking you to pull your data when you flipped 2 coins. Okay? And then you're going to calculate your chi-squared. Okay? And so the calculation for chi-squared is the sum of your observed minus your expected, which you have already calculated. When you go do your probabilities, you'll do that calculation. You take that number, square it, and then you're going to divide it by your expected. Okay? And so the sum means that you have to do it for each of your scenarios. You have to do it for when you had 2 heads, you need to do a chi-squared. Okay? So you have, it's the chi-squared is the sum of all of those. Does that make sense? So you're going to take all of your observed minus your expected, square it, and then divide it by your expected. That gives you your chi-squared number. Okay? Now chi-square is basically a calculation to determine if this difference that you're seeing between your observed and your expected is accepted or we reject it, meaning we accept that those differences is just by chance. We reject it if we realize that that difference is too big and there has to be something that's causing the difference between our observed and expected. Okay? So once you get your chi-squared, you're then going to use that number on page 60. Okay? And so you take your chi-squared number, and then you're going to take your degree of freedom. Has anybody done chi-squared before? Like a while ago? Got to be a little refresher. Okay.
Okay, we're gonna do page 64, then we're gonna go back to 60.
Well, 60 has the chart that you'll need, because that's your chi-squared chart.
Oh, okay.
Okay. And so the degrees of freedom is the one less of the number of terms. So basically, if we're looking at 3 situations, 3 minus 1, that would give us our degree of freedom. So we're looking at, like your first flip of the coin, we're just looking at the difference between heads and tails, right? 2 situations we're looking at. So 2 minus 1, that means our degree of freedom is 1. So you find on that chart on page 60, you would find your degree of freedom. You would take your chi-squared value. You would find it in there, and then you would look to see if the p-value, what the p-value is. Okay? Everybody's good? No? Yes? When you get there, we'll talk about it more. Okay? So go ahead and flip your coins. Your coins should be the same. I forgot to I have like tons of change in my car, and I forgot to grab it this morning, so I grabbed what I had in my purse, and I had just pennies. I'm not a cash carrier. I'm not. And coins